This video is part of my paid course called Pragmatic .NET Code Rules. I decided to release this section completely for free on YouTube because I genuinely think every .NET developer should understand this stuff. And trust me, if you care about writing production-ready .NET applications, watch this until the end. And also you will get some gifts. A lot of .NET developers think code quality starts with architecture. Clean architecture, CQRS, vertical slices architecture, microservices. But honestly, most projects become messy much earlier than that. It starts when every developer formats code differently. Different naming, different spacing, different standards at all. And after 6 months, the code base starts feeling heavy. Peer reviews become annoying, refactoring becomes risky, junior developers copy inconsistent patterns. So in this video, I want to show you one of the most underrated things in modern .NET development, the EditorConfig file. I'll show you why serious teams rely on it, how it actually works behind the scenes, and how to use it properly in the real projects. So we will first talk about why code style consistency actually matters in real teams, then we'll create a proper solution structure, and finally I'll explain what EditorConfig really is and how Visual Studio and Roslyn use it under the hood. Let's start. Why code style consistency really matters. This is not about production system. Let's elevate this beyond formatting is important. When you look at the production system, what really costs money? Bugs cost money, slow code reviews cost money, onboarding friction, merge conflicts cost money, context switching also costs money. Style inconsistency directly contributes to all of them. Most developers think formatting is harmless, but it's not. In real repositories, formatting changes accumulate invisibly. Imagine this. A developer updates one method but uses different formatting settings. Git now sees indentation changes, brace alignment changes, white space normalization, possibly namespace restructuring. The actual logic change is buried inside noise. This reduces signal to noise ratio in code reviews. Production impact here is huge. Reviewers miss subtle logic errors. Review time increases while trust in devs decreases. Once developers stop trusting difference, review quality drops. That's not theoretical. That's how bugs escape. Human brains recognize patterns faster than they parse syntax. Consistent formatting creates predictable visual structure. Indentation depth signals scope. Brace placement signal boundaries. Namespace structure signal architecture. When formatting varies, the brain spends time reparsing structure instead of reasoning about behavior. This affects debugging speed, feature understanding, incident resolution time. Consistency reduces mental overhead. That is real production value. So the core principle here is that style consistency is not about aesthetics. It's about reducing friction in collaborative systems. And here, EditorConfig file is first systemic solution. We have centralized rule definition, ID enforcements, automated cleanup, and CI integration. At the end, I would like to say that clean code is not written, clean code is enforced. So let's go to another submodule and let's set up our solution structure. Before adding any rules, we need some starting point. So for that case, I'm going to create a basic clean architecture structure empty project. So let's do that. I'm going to create a new web API project. Let's name it newsletter.api, and I'm going to have solution newsletter. Let's create this one. I will go to program CS and I'm going to remove most of the things we have here. And I'm going just to make basic get endpoint. Let's say it's a health check endpoint and I will return results. Okay, let's quickly run it. So application is up and running. In addition, I'm going to create one class library. Let's name it newsletter domain project. We will add 2 more projects, newsletter application layer, and another one is newsletter infrastructure layer. And here I'm going to create another project which will be test project, so XUnit test project, and let's name it newsletter tests. In order to make it more clean, I'm going to add solution folder, name it source, and another tests. All of those source projects I will move to the source folder, and our newsletter tests project, I will move to test projects. Let's build it. So that's it. We have everything to start. Let's go to EditorConfig and how to use it. What EditorConfig actually is? Let's start with a precise definition. EditorConfig is a repository level contract for editor behavior. It's a plain text.editorconfig that lives in your repository and describes code style and formatting preferences in a way that multiple tools can understand it. So the key word here is contract. The moment the contract is committed to source control, the rules of writing code stop living in someone's repository in localhost and start living in the one place that matters. So that single decision has massive consequences in production because production teams are rarely homogeneous. You will have developers using Visual Studio Code or somebody using Rider, and all of them will produce commits into the same Git history. Without a shared contract, the repository becomes a battleground of invisible defaults. Formatting changes appear randomly, PRs become noisy, and every change feels harder to review than it should be. Now here's the part that most developers misunderstood. EditorConfig does not format code on its own. It declares intent. Indentation should be spaces, indentation which should be full, file scope namespaces are preferred, braces are required, and so on. Then your IDE or tooling decides how to apply that intent. Quick demo what EditorConfig file is. So here in solution items, so this is on a repository level, here is the basic EditorConfig file. Don't worry how to create it, how to populate it and use it. We will learn that in next module. But for now, this file does nothing by itself. It just declares intent. Tools execute that intent. So who reads EditorConfig? In .NET, there are two big consumers of this intent. The first one is the formatter. That is the thing that changes white spaces, indentation, brace placement, and layout. And another one is Roslyn analyzers or ID diagnostics, the thing that emits suggestions, warnings, errors like remove unused usings or prefer braces, etc. EditorConfig can influence both. Some settings are pure formatting directives, indent size, trim trailing white space, etc. Other settings are style preferences that Roslyn understands, and they can generate suggestions or warnings depending on severity you choose. So let's quickly return back to EditorConfig and see the demo with formatting. So here we are in the same EditorConfig file from a root of the solution. So let's see how our Visual Studio ID will work with EditorConfig file. For example, let's see indent size. I think everybody knows that indent size defines the visual width of a tab are used for a single level of indentation in our code. Most common value is 4. So let's go to program CS and let's write some code to see how this is going to look like. Let's say, for example, we have some numbers and let's say we have an array of the numbers. Now we want to select some result. Okay, let's do that. And let's do select where we are going to have some condition and we are going to return list. So you can see that our indentation is structural in that way that each indentation has 4 characters of indent size. If I go back to EditorConfig and let's say I change indent size to 2 and now go back, of course nothing happens, but let's say I'm going to run code cleanup, about which we are going to talk a little bit later, and if I run it, you can see that now indentation is only 2 characters. That was a quick demo of formatter. Let's see about Roslyn analyzers. So I'm going to search for namespaces. The code of .NET diagnostics for namespace is that one, and we have severity, about which also we are going to talk a little bit later. But this is the rule that tells Roslyn analyzer if you see unused directive in your code. Let's see this on example. I'm going back to program CS and let's say I'm going to say using system link queue, I'm going to say maybe something like that, and let's use for example OpenAI. If I build this project in error list, I'm not going to see any errors, neither warnings, neither messages, info messages, because we put that severity for this is none, so it's completely unnecessary. Let's say I'm going to put error. What's going to happen? You can immediately see that we have errors with using directives because this using is unnecessary. And of course, in the error list, you will see the same message. And yes, if you run code cleanup again, it will solve that for you. And yes, for severity, you also can put warning. And if you go back to program CS, you will have using directive is unnecessary and you will have that green underline for each using directive. So let's go back to slides and figure out how EditorConfig file is even discovered. So how EditorConfig is discovered? This is a production critical knowledge. When ID is editing a file, it needs to find the rules that apply to that file. The rules are not global by default, they are hierarchical. The discovery algorithm is quite simple. Start in the directory of the file being edited. For example, in this case, this is going to be EditorConfig file in source. Look for EditorConfig file. If not found, or even if found, walk up the directory tree. Merge settings from any EditorConfig files you encounter and stop when you hit a file containing root equal to true or the file system root. So in this case, EditorConfig in our source file will override inside source. That hierarchy is the reason EditorConfig file is production friendly. Real repositories need different rules in different places. For example, you might want strict rules in source files but relaxed in test files. You might want to exclude diagnostics from generated code, or maybe you might want different indentation or formatting for markdown files, YAML files, JSON files, etc. Generated code is often huge, noisy, and not meant to be hand edited. If you apply strict rules to generated output, you create constant churn and meaningless warnings. Let's see that in action. As you already know, we have EditorConfig file on a solution level, and as we saw from the slides, we can create EditorConfig, for example, in newsletter API specific. So let's say I'm going to create a new EditorConfig file on just API project level. So let's go and create new EditorConfig, and we have generated EditorConfig file in our newsletter API project. Let's just copy those three rules that we had already and let's just paste it. As you can see, in this EditorConfig file, we don't have a root equal true because it's not a root EditorConfig file, and that's by default. Let's see what will happen if we, for example, have some default values for indent size in our root EditorConfig file, but for some reason in our EditorConfig file in the project directly, I want to put indent size, for example, 20. Let's go to program.cs just to see that in action, and let's go to run code cleanup. As you can see, we have something really ugly here. So this EditorConfig file in project overrides the root config file, but also will take all other rules that are in EditorConfig file in root, which are not, let's say, in child EditorConfig file. So why is this useful? Most of the time I found it useful is because I wanted to separate EditorConfig files for source and for the tests, because I didn't want to have some strict rules for test projects. Now when we know how EditorConfig file is discovered, we need to learn about three main pillars here, which are scope, value, and severity. Let's learn that. All of those three can be explained through one question for each. For the scope, the question is, where does this rule apply? For the value, what do we want? And for severity, how much do we care? So in the example below, you can see that scope are all CS files, C# files. Value is file scope for namespace declarations, and severity here is warning. So for the scope, the main question is, where does this rule apply? And here we had that EditorConfig uses section headers like those three, and this is not decoration. This is how you prevent rules from spilling into places where they don't belong. For example, the first one means all files. The second one is C# files and all C# script files. And the last one, anything under a folder name generated anywhere in the repository. So this matters in production because repositories are not only the code, they are also CI, YAML files, Docker files, JSON files, Markdown documentations, SQL scripts, front-end assets sometimes, etc. So without scoping, you end up applying code-like rules to non-code files or ignoring important consistency in documentations or configuration files. What about value? What do we want? Examples. For indent size, we have 4, so that's a numeric value. For insert final new line, we have boolean value, can be true or false. And for namespace declaration, as we already saw, we have file scope value. These express the desired behavior. And the third one is severity. How much do we care? So from Roslyn driven style, we have three main severities: suggestions, warnings, and errors. And this is where production readiness lives. If you make everything an error from the day one, you get rebellion. If you make everything a suggestion forever, you get drift. The mature approach here is to start pragmatic, then tighten the rules as the team stabilizes. That's not motivational talk, it's change management for engineering systems. So a common production progression we can see here is to start with formatting, a handful of high signal warnings, like unused usings. The next step would be keep controversial preferences as suggestions. Later, you can enforce, promote specific rules to errors if the team agrees. And that progression prevents tool rejection, which is a real problem in real teams. And now we can learn how to make your first editor config file. So this was only a small part of module 1 from my course Pragmatic .NET Code Rules. And the funny thing is, this still ended up being almost 20 minutes long. The full module and course go much deeper. We configure real production-ready rules, automate cleanup, enforce standards in teams, integrate analyzers, CI validation, Git hooks, and much more. The goal of this course is not just to explain theory, the goal is to help you build projects that stay maintainable even after years of development. Also important thing here, there are no subscriptions, no hidden tiers, no monthly payments. You buy the course once and get permanent access, including access to private community where you can ask me questions directly. Right now the course is still in pre-sale phase because I'm actively recording and releasing remaining modules, which also means that current price is temporary. As more modules get added, the price will increase and the pre-sale offer will disappear. And because of you watched this video until the end, I want to give you a small discount code as well. You can use YouTube 20 for 20% off of the current pre-sale price. You can find everything in the description below. And honestly, if you don't even buy this course, I hope this video changed the way you approach code quality in .NET project. If you like this video, please hit that button, subscribe, hit that like button, and see you in the next video. Dream big.